Here we have parallel lines here and here, and asked to identify the angle marked X. Well, we can see here that we have an F shape here and here, which means that this angle and this angle are the same. We call this corresponding. So the size of angle marked X is 55 degrees. Here we have a scatter graph that shows some information about 10 cars. It shows the time, shown here on the x-axis, and for each car, the maximum speed, here on the y-axis. First, we're asked to identify what type of correlation the scatter graph shows. You can see here our points are going down from left to right, so our correlation is negative. We're then told that the time a car takes to go from 0 to 60 miles per hour is 11 seconds, and asked to estimate the maximum speed. So we have 11 here on the x-axis. First, we need to draw our line of best fit. So taking your ruler, you need to place your ruler approximately in the middle of these points. So roughly the same number of points below as above the line. Then taking your ruler again, from the 11, drawing a vertical line up to your line of best fit and across. So we can see here that an estimate for the maximum speed is 120. Now this answer will depend on where you have drawn your line of best fit. And in the exam, the examiner will allow an answer as low as 117 and as high as 123. So make sure your answer is somewhere between 117 and 123. This diagram shows a square and 4 regular pentagons. We need to work out the angle marked here, X. Let's take a look at our pentagon. Our pentagon has 5 sides. We need to work out the interior angle here, which will be the same as here. So there's 2 ways to work out the interior angle of a regular pentagon. First, we can work out the exterior angle. Now for all polygons, the exterior angles add up to 360. So we simply divide 360 by 5 to give us the exterior angle of 72 degrees. Now using this, we can take away from 180 to find the interior angle of 108 degrees, as interior and exterior add up to 180. Now we can work this out by taking the number of sides, subtracting 2, multiplying by 180, which gives us our total for the interior as 540. We want to know one of the interiors, so divide through by 5 and we get to 108. So here we have 108, here also 108. Now as this is a square, our angle here is 90. Adding up 108, 108 and 90 gives us a total of 306. Now right here we have a point. All of these angles are around the point and add up to 360. Subtracting 306, we are left with 54. So the missing angle X is equal to 54. A rugby team played 6 games. The mean score for the 6 games is 14.5. So we add up the total, we don't know, divide by 6, the number of games, to get the mean of 14.5. So to find the total of these games, the 6 games, we must multiply 14.5 by 6. The total of the 6 games is 87. Now we're told the rugby team played 1 more game, so we now have 7 games, and the total, the mean, was 16. we need to work out the number of points scored in the 7th game. So we have the total for the 6 games. Then we have to add here the 7th game score, which we don't know. Divide by 7 games now, to get the mean of 16. So here we formed an equation to be able to find the missing number of points scored here in the 7th game. So times here by 7, 87 plus x, is equal to 112. So here now to find x, 112 subtract 87 is equal to 25. So the number of points scored in the 7th game is equal to 25. The nth term of a number sequence is 3n plus 1. We're asked to work out the first 2 terms, when n is equal to 1 and n is equal to 2. So first we have 3 times 1, add 1. 3 times 1 is 3, plus 1 is equal to 4. Now when n equals 2, 3 times 2 is 6, plus 1 is equal to 7. Now we have another sequence and asked to find the nth term. Our first step is to identify the difference of the sequence. We can see here that we are adding 4 each time. Therefore, the sequence is related to the 4 times table, 4n. So how does the sequence compare to the 4 times table? Well, the 4 times table goes 4, 8, 12, 16. Now we don't want 4, we want 1. We don't want 8, we want 5. So we must subtract 3 each time. So our nth term is 4n, take away 3. Here we're given an equation, y equals 4x minus 3. A table of values partly completed and axes here to plot the graph. So let's look first when x is minus 1. So replacing here our x by minus 1, 4 times minus 1, take away 3. 4 times minus 1 is minus 4, take away 3 is going to give us minus 7. Looking now when x is equal to 1. 4 times 1, take away 3. 4 times 1, 4. Subtract 3 leaves us with 1. So 1 for y. Lastly here, we'll look at 2. X is equal to 2. 4 times 2, take away 3. 4 times 2 is 8. Take away 3 gives us our value of 5. You will also notice along here that the difference between each of these values is 4. When you plot these now onto your graph, if they do not form a straight line, you've made a mistake. Let's take a look. Our first coordinate shown here is 2, minus 2 for x, and minus 11 for y. So x-axis along to minus 2, y-axis down to negative 11 here. Plot with a cross as opposed to a dot. It's a lot more obvious to show the examiner where your coordinate is. Next coordinate, minus 1, minus 7. So negative 1 on x, negative 7 on y, just there. Then we have 0, minus 3 here. 1, 1, 2, 5, and 3, 9. You can see it forming a straight line. Taking your ruler out now to connect all of these coordinates to form a straight line. So connecting your first one, ruler through, using a pencil, and there. So check that the line passes through all of the coordinates you have plotted on your graph. Here we have a triangle and asked to shade a particular region inside the triangle. There's two parts to this question. The first is saying that the region is less than 3 centimetres from point B. So for this part, we're going to have to put our sharp point of our compass on B and draw a circle round which has a radius of 4 centimetres, this part here. Then we need to draw a line that bisects where we have AC. AC is here, and then we have AB here. So we're going to need to do a bisector along here to find the line so we can see it's closer to AC than it is to AB. So let's take a look at the first part. Taking your compass and ruler, you're going to mark out to 4 centimetres. So stretch your compass to 4 centimetres. Take it away from the ruler and put the sharp point here on B. Now taking your pencil, going round, you're going to draw an arc that crosses here and here. And take that away. So the point, the region, is less than 4 centimetres away from B. So it's got to be somewhere in here. So the next part is to bisect this angle here. So we're going to take our compass again, change the colour of my pen here, and we're going to put our sharp point on, a bit smaller, our sharp point here on A. Now we're going to do an arc that crosses here, AC, and here at AB. Once you've done that, it's really important you don't change the length between the sharp point and your pencil. Take your compass now and look at the crossing point here on the line AB. I'm going to draw an arc around. Oh, I've just moved it. I'm going to have to go back and check, get that into exactly the right position. So here. Okay, so as I said, don't adjust. Move your sharp point here. And now drawing an arc right the way around. Lift up, go to the crossing point on the other side, and draw an arc in exactly the same way. And the two arcs that you've just drawn need to overlap. You can see here is our overlapping point. Taking your ruler, now go to the corner here of A, go straight down through the crossing point here. So now we can see our defined region. So reading back through, the region, the part that we're looking for is less than 3 centimetres. It's got to be on this side of the line, but it's closer to AC than it is to AB. So it's got to be on the other side. So we're looking at a point, our region, in the yellow section shown here on the screen now. So this yellow section satisfies both points here, being less than 3 centimetres from B, but closer to AC than AB. Potatoes cost £9 for 12.5 kilograms. This is at the farm. The same type of potatoes at the supermarket cost £1.83 for 2.5 kilograms. We need to work out which is better value, the farm or the supermarket. To do this, we need to find the price for 1 kilogram so that we can compare the price for the same quantity. So let's take a look. Going from 12.5 to 1, we need to divide by 12.5. Here, we will be dividing by 2.5. So we do the same with our price. Divide 9 by 12.5 and here divide 1.83 divided by 2.5. Putting that into your calculator, you have the price here as 0.72, which is 72 pence. And here at the supermarket, the price for the same amount, 0.732. We can ignore the 2 here because we're talking about money, so we only need 2 decimal places, and 2 is a small number, so 3 doesn't round up. So these now here are the 2 prices that we're comparing. This is a lower amount, so the farm is better value. $0.72 is less than 73. So the key there is taking your amount to the same weight so that you can compare the prices. We're told that a particular region satisfies the following 3 inequalities and asked to shade the region shown here on the graph. So let's take each inequality. First, we have x is greater than or equal to 2. So we need to take our ruler and draw a line at x here equaling 2. So our inequality states that x is greater than or equal to, so it's in this direction. Now our second line, y is greater than or equal to 1. So taking your ruler again, this time going to y, 1, drawing a line across. So again, we're looking at greater than, so it will be in this area. Then we have the equation x plus y equals 6. So remembering where we plot x plus y equals 6. Well, if x is equal to 6, y must equal to 0. They add up. 2 values adding up to 6. Similarly here, if x is 0, y will be 6. X is 1, y is 5. We have here 1 plus 5 equals our 6. We're looking at our values. So you can see here that the line x plus y being 6 goes across here. So let's take our ruler again to draw our third line here. Now this time it says x plus y is less than or equal to 6. So we're going in this direction here. So we can now see the region R is here in the triangle formed between the 3 lines. This diagram shows a circular pond with a path around it, shown here. We need to find the area of the path, the shaded section. So we must find the area of the large circle and subtract the small circle. To be able to find the difference, here, the shaded part grey. The large circle is pi multiplied by 6 squared. The area is the 5 plus the 1 for the big circle. The small circle is pi times the radius, 5 squared. Putting that into your calculator using your pi button, we have 34.5575, giving our answer correct as 3 significant figures, 1, 2, 3, draw your line. Here we have a large number, 5 is a big number, so the number in front goes up to give our final answer of 34.6. The diagram here shows a cube and a cuboid. All measurements are in centimetres, and we're told that the volume of the cube is 100 centimetres cubed. More than the volume of the cuboid. So this plus the cuboid is going to equal the volume of the cube here. So we're asked to show that this equation is true. So first, if we take the volume of the cube and we state that this is equal to 100 centimetres cubed plus the volume of the cuboid. So the volume of the cube, we can see our three dimensions here are just x, as they're all the same, to the power 3. Then have 100 plus the volume of the cuboid, which here we have 2 times 5 times x, which is 10x. Rearranging this, we can see that x cubed minus 10x is equal to 100, as shown here in part A. We then need to use trial improvement method to find the value of x correct one decimal place. To do that, we make a small table with our values for x that we are going to try, show our working for x to the power 3 minus 10x, and then I'll comment whether the number is too high or too low. Now remember, we're comparing this to the 100. So first off, if we take the value 5, substituting in here, 5 to the power 3 minus 10 times 5 gives us 75, which we can see in comparison to the 100 is too low. Taking now the 6, substituting in 156, which is too high. So let's go halfway, 5.5. Substituting in 5.5, we get the answer of 111. Again, in comparison to the 100, still too high. Go down again to 5.4, which gives us an answer of 103. Closer, but still too high. 5.3, trying now, gives us 95.877, which is too low. Now this is the situation we are looking for, where we have here consecutive 5.4, 5.3, and here one's too high, one's too low. So we must now go halfway between to do a check. So taking now, substituting 5.35. Doing this, our answer comes out at 99.6. So 5.3 high is still too low. Therefore, our answer is closest, correct one decimal place, to 5.4. Here we have a right angle triangle. We need to find QR. This is a right angle triangle. We must use Pythagoras. When we go across from the right angle, we see the hypotenuse, the longest side. We have the hypotenuse, so we are going to be subtracting. 16 squared, take away 8 squared. Gives us 192. Square root 192 gives us 13.856. 40646. Now we need to give our answer correct to 2 decimal places. Go to the decimal point, move 2, 1, 2, draw a line. The number after the line is a big number, so the number in front goes up. Our answer correct to 2 decimal places is 13.86. Here we're asked to describe the single transformation that changes A onto B. We can see here that we have an enlargement. The first mark is from stating the correct transformation, enlargement. Second, we must state the scale factor, what the lengths have been multiplied by. So taking a look here, we have 1, 2, 3, 4, and 4 down here, and we started with 2. So our scale factor is 2. We have multiplied the lengths by 2. Similarly here on the diagonal, we can see 1, 2, and here 1, 2, 3, 4. Now we must find the centre of enlargement. This is the coordinates. To do this, you need to take your ruler and match up corresponding points. So first we can take our value, our coordinate from here, the corner, and match it with here and continue backwards. Again, taking our corner here where the right angle is with the corner here, extending backwards, and then our third corner here, matching up with the corresponding corner, extending forward. And you will notice that all of the lines will meet at one particular point, shown here. This is the centre of enlargement. So here we must write the coordinates 5, 6. A family went on holiday to Miami. They travelled from London by plane. The distance from London to Miami was 7,120 kilometres. The plane took 8 hours. We need to calculate the speed. So the triangle, the formula triangle we will use is speed, distance, time. We need to calculate the speed. The distance is 7,120 kilometres and the time is 8 hours. We're asked to give our answer in kilometres per hour. So looking here, our distance is in kilometres, our time is in hours. So to find the speed, we can simply take our distance and divide by our hours to give us a speed of 890 kilometres per hour. Here we have the times in minutes recorded to repair 80 tyre wheels, car tyre wheels. So here we're looking at grouped data. First, we need to find the midpoint of each of the groups. Between 0 and 6, 3. 6 and 12, 9, 15, 21 and 27. Now we have the midpoints. We multiply each midpoint by the frequency. So we have the midpoint times the frequency. So here, 45, 225, 300, 252, and 216. Now, if we're going to work out an estimate for the mean, we need to find the total here and the total here. We take this total and divide by the total of the frequencies. So we have 1,038 divided by 80, the number of car tyres, equals 12.975. In a sale, the normal price of a book is reduced. That means a decrease by 10%. So we start with 100%. We're going to subtract 10% because it's a reduction, which gives us 90%. 90% as a multiplier, divided by 100, is 0.9. So we're told that the sale price is £4.86. This is the sale price. So the normal price we need to find, we would normally times that by 0.9 to give us the sale price of £4.86. Therefore, to find the normal price before the sale, £4.86 divided by 0.9, which gives us our sale price of £5.40. Here we have some information about the speeds of 100 lorries. We need to draw a cumulative frequency graph. First, we must find the cumulative frequency. We do this by taking our first row and putting it here too. This gives us our first. We must then add 9, which gives us 11. We then add 23, which gives us 34. We then add 31 to give us 65. Add 27, 92, add 8, which gives us 100. You need to check that this corresponds with what's given in the question. So our cumulative frequency is shown here on the screen now. To plot this, we must take the upper class of the boundary, which is these values here, which are here for the speed, and then the cumulative frequency, plotting here on the y-axis. So taking a look at our scale, we can see here that we're going to be going at 20, 40, 60, 80, 100, 120. And on our y-axis here, we have between 0 and 20, we have 10 squares. So this will be equal to 10 here, so each square is worth 2. So our first value here for 20 and 2 is 1 square up. And for 40 and 11, we go to 10 and then half a square. 60 and 34, up to 30, 2 more squares. 80 up to 65, so 2 squares and a half. 192. And then 120, and up to our final value here for 100. Now the points are plotted, you need to take your pencil and draw a smooth S-shaped curve. Really important, you need to start here at the origin, swing up, and then across. That's quite difficult for me to do here on the computer to show you, so take it really carefully from our 0, our origin point. We're going to go down here, start coming up, and it should be one continuous smooth curve. You can probably do a better job than I can shown here on the computer with a smooth curve up. Now we're going to use this curve to estimate the number of lorries with a speed of more than 90. This more than is really important. So 90 is shown here on our graph. So taking your ruler, we need to draw a vertical line up at 90. So here to our cumulative frequency graph. Then going across, lining up, we can see here that the value coming out on the XY axis here that corresponds with the 90 is equal to 80. But we're interested in those that go more than 90, which are these lorries here. So 100 subtract 80 gives us the number of lorries as 20. Really important you do the subtraction here at the end. Here we're asked to find the value of 16 to the power negative 3 over 4. Our first step is to deal with the negative. So to remove the negative, we must put this as a reciprocal under 1. This makes our power now positive. Next step is to deal here with our root. This part, the denominator, is the root, and our 3 here is our power. So we're looking for the 4th root of 16 to the power 3. The 4th root of 16 is which number multiplied by itself 4 times gives us 16. The value is 2. So we have 2 to the power 3, 2 times 2 times 2, which gives us 1 over 8. We then have an expression here with a third as the denominator. We need to rationalize the denominator. To do that, we multiply by the denominator to root 2. But we will multiply the numerator as well as the denominator. The root 2 needs to be multiplied by the 8 and the negative root 18. So 8 times root 2 gives us 8 root 2. Root 18 times root 2 gives us root 36. We times our 2 by our 18. We have a negative here, root 36, divided by root 2 times root 2, the rule of thirds, if these two values are the same, we simply have 2. Now we can work out this one as an integer value 6. So we have 8, root 2, take away 6, divided by 2. Simplifying through now, cancel our 2 with our 8 to get 4, and cancel our 2 here with our 6 to get 3. So we're left with negative 3 plus 4 root 2. So what we're asked for here, A is negative 3 and B is equal to 4. Here we're asked to make T the subject of the formula. That means we want T on its own and everything else on the other side. The first step, we must multiply out the bracket. So we have 2D minus 2T, and on the other side, 4T plus 7. Now we've multiplied out the bracket, we need to get all of our T's together. So let's remove this by adding 2T to both sides, which leaves us with 2D equals, add 2T. We're going to have 6T now plus 7. Next step, let's remove this 7. So subtract 7, subtract 7. 2D, subtract 7 equals 6T. Now we don't want the 6 there in front. It currently says 6 times T, so we must do the opposite by dividing by 6, which leaves us with T. 2D minus 7. We must also divide this side by 6. So all over 6 gives us T as the subject of the formula. This question is about proportionality. We're told here that Q is inversely proportional. That means K over the square of T, T squared. So Q proportionally but inverse, so the T goes underneath, it's divided by K, a constant, and it's T squared. We must now write that with an equal here. Then using our two values for T and Q, substituting to find K. 8.5 is equal to K divided by 4 squared. So K is equal to 8.5 times 16 all squared. 8.5 times 16 is equal here now to 136. We can then put K back here to write the formula. So we have Q equals 136 divided by T squared. Now using this, we need to calculate the value of Q when T is equal to 5. So Q is equal to 136 divided by T is 5 squared. So Q is equal to 136 divided by 25, which is equal to 5.44. Here we have an incomplete grid histogram and an incomplete table. First thing we need to write down is to remember that frequency density is equal to frequency divided by class width. So therefore, frequency is equal to frequency density times class width. These two times together make our frequency. We're going to need that to find our missing parts. So let's take a look. In our first row here, we have the information for the frequency and we have the bar. So we're going to use this to help us. Let's find the class width first. So the class width is the space here between 0 and 1,000, which is 1,000. So to find the frequency density here, we're going to take our frequency, 16, and divide by 1,000, which gives us our frequency density of 0.016. This means here is equal to 0.016. We can now use this to work out the scale. So going backwards, we can see here we can split into 4. Halfway will be 0.08. Half of this, 0.008, which will be here 0.04, and here 0.012. Again, halfway here, we're looking at 0.002, here 0.006, 0.01, and then here 0.014. Okay, so now here for the next part, the bar here, we can see up here, if we're adding on a further 0.002, this will be 0.018. So here our frequency density is 0.018. To find our frequency, we must times this by 1000, our class width here, to find here our frequency, which is 18. Our next bar, our class width, is 2000. Then again, 2000, 2000, and lastly here, 4000. So now moving on to our third bar, we can see here that our frequency density is 0.01. Timesing by 2000 gives us our frequency of 20. Lastly here, we have 0.006. Timesing here by our class width 2000 gives us our frequency here of 12. So we now have our table completed. We need to finish off the histogram. So looking here, we're going to find our frequency density, our frequency, 16 divided by 2000, and here 8 divided by 4000. So first here, our frequency density for the 16 is equal to 0.008, and here 0.002. So taking our ruler between our 4000 and our 6000, we need to go as high as 0.08. So now we need to plot these two here onto the graph. First, between 4000 and 6000, we have a frequency density of 0.08. So drawing a line across here and down here to complete the bar. And then moving on to our final bar here, between 8000 and 12,000, 0.002. So a bar going across here. And again here to complete the bar. So here now we have our completed histogram and table. Here we have two quadrilaterals, and we're told that these shapes are mathematically similar. This means that their lines are in proportion. First, we must look and to find two corresponding sides where we have both the measurements available. We can see here across the top. We take our second value, our largest, and divide by our first value to find our multiplier here of 1.5. That means when we go from this shape to this shape, we times by 1.5, and we go in this direction, we divide by 1.5. So first looking at the length PQ. To find the length PQ, we take our 6 and we times by 1.5 to give our length of 9. And then to find AD, here we take 12, we divide by 1.5 to give our length of 8 centimetres. In this question, we have a quadratic and we're asked to solve it, giving our answer correct to 3 significant figures. When it tells you to round to 3 significant figures, it means you must use the formula. This is printed at the front of your exam booklet. The formula states that x equals minus b plus minus square root of b squared minus 4ac all divided by 2a. So first we need to identify our A, B and C. Our A is the number sitting here, the coefficient of x squared. That's equal to 3. B is the coefficient sitting here in front of the x, which is negative 4. The negative part is really important. Here, C, this is the number here on its own, the number. So we have negative 2. We then need to put everything into the correct place by substituting. So we start here with our value here of x equals minus. Now we replace the b, which is minus 4. Plus, minus, that was all there before, the square root of b squared. Minus 4 all squared. Then we take away, the take away was there first, 4 times. Now we have our values here for A, 3 times negative 2. All divided by 2 times our value for A, which is 3. Okay, so let's take a look here now. First, we have 2 negatives here together, which makes a positive. 2 times 3 is 6. Minus 4 squared is going to give us positive 16. Here we have minus 4 times 3, which is minus 12, times minus 2, which is positive 24. So we will be adding these two values here, 16 plus our 24, to make 40, the number inside the square root. So simplifying that now, we simply have 4 plus and minus square root of 40 divided by 6. Putting that into our calculator twice, once we will do x equals 4 plus the square root of 40 divided by 6, and then x equals 4 subtract the square root of 40 all divided by 6. Doing that will give our two values for x, 1.72 and negative 0.387. Here now we have a rectangle. We're told that the length and the width is correct to the nearest centimetre. This means that the length for the upper bound can be as high as 35.5 and the lower bound will be 34.5. For the width here for 26, the upper bound will be 26.5 and the lower bound will be 25.5. We need to calculate the area for the upper bound. To find the area of the upper bound, we are going to take the upper bound for the width and multiply it by the upper bound for the length to give us the biggest possible answer. So we will have 26.5 multiplied by 35.5, which gives us our area of 940.75. This table gives information about the number of students in 2 years of a college course. Anna wants to interview some of these students. She wants to take a random sample of 700 students stratified by year and gender. We're asked to write down the number of male in their first year. So male in first year is 399. 399 divided by the total. We must add up these 4 to give our total, which is 1451. Times by the sample size, which is 70, which gives us our number of 19.249. Now we can't have 19.2 males, so we must round, which gives us 19 males in their first year to be in the sample. This question is about vectors. First, we find the vector AB. We see here A to B in this direction. So we need to go backwards on the A and forwards on the B. So that's negative A, positive B. Negative A plus B. So we're going the direction A to B, backwards, forwards here. We're told that the point P here is on this line AB, and A to P is 2 to 1 P to B. And we need to find the vector OP. So first step is to draw in OP onto your diagram. Remember to write the direction in, starting at O and going here. So we could go up and down, or we could go down here and up. Let's go up. So here we have A plus, in this direction, but not the whole way. Only 2/3 of the way, 2 out of the 3. And this vector we found in part A, which was minus A plus B. Simplifying by multiplying out your bracket, expanding your brackets, we have here A minus 2 over 3A plus 2 over 3B. Simplifying here, we have a third A plus 2/3 B. This is our vector from O to P. Here we're asked to calculate the area of the triangle. We must use our formula, half times A times B times sine C. A and B are our two sides here. It doesn't matter which way round, but one is A and one is B. And our angle here in the middle is our sine part, sine 75. So substituting into our calculator, writing down our formula and our working out, gives us our answer here of 19.3, correct to 3 significant figures. We're then asked to calculate the length AB, so we need to find this side here. So we have given our side, our angle, and we need to find the side missing here. We therefore are going to use the cosine rule. Again, the cosine rule is stated on the front of your formula sheet, that A squared equals B squared plus C squared. Take away 2 times B times C times cos A. So here we have our two values for A and B are on the sides here, and our angle here will be in the middle. So we're going to use this, that this and this must now correspond to A, because this is related to where the angle is. These two sides here have to be our B and our C. Doesn't matter which way round, but this part must now be our A. So A squared is equal to 5 squared plus 8 squared minus 2 times 5 times 8 times cos 75. Putting it all into your calculator, you will get your answer for A squared, which is 68.29447,639. But we want to know A. So from here to here, we must square root, which gives our answer correct to 3 figures, 8.26. Here we're asked to simplify our expression here. Both are quadratics. We must therefore factorise. So the numerator here, our coefficient, the number in front of x squared is 1. So we simply have x bracket x close bracket. So to find out our two values here, we're multiplying our 1 by our 4 to get 4. Factors of 4, 1 times 4, 2 times 2. We need to make 3 here in the middle. So we're going to take 4, take away 1, which gives us 3. So here we will have plus 4 and here minus 1. The next part's slightly different because here our coefficient of x squared is 2. So we must put in an extra step. First, we take our 2 times our 3, which gives us 6. Back to the 6, 1 times 6, 2 times 3. We need to make negative 5. Now we can do that in both ways. We could have minus 6 plus 1 gives us negative 5, or minus 2 minus 3 gives us negative 5. But we need to have a look here. Whilst this is negative, which we can make, our last term here, our plus 3 at the end, is positive. Therefore, we need to take this set to be able to make a positive number here, our two negatives together. So taking a look now, we're going to write out the middle term, minus 5x, into the two parts. So 2x squared minus 2x minus 3x plus 3. So this term here, minus 5x, has been split into two parts. That then enables us to factorise. So first off, looking at our first two terms, take out our common factor of 2 and x, close brackets, x, take away 1. In our next part, taking out a factor of minus 3, so that we have the minus 1. Taking out our minus 3 here, we have x, take away 1. Putting those together now, so we have 2x, take away 3, and x, take away 1. These go underneath here, 2x minus 3, and x, take away 1. We can cancel out our two parts here, and our final answer is x plus 4 over 2x subtract 3. Now taking a look at the next part. Here we're asked to write this fraction added this fraction with algebraic terms as a single fraction. But just like if we were doing fractions just with numbers, if we had 1 over 4 plus 7 over 9, we would take our denominator here, times by 9, times by 9, our denominator here, times by 4, times by 4. So we're going to do exactly the same thing. The denominator here, we times up here, and here, times here and here. So on our top here, in the numerator, we will then have 4 bracket x minus 2 plus 3 bracket x plus 2. All over 2 terms together, multiplied together, minus 2. Okay, simplifying through here, we have 4x, take away 8, plus 3x, add 6. Simplifying this through, we're going to have 7x, take away 2, all over x plus 2 bracket, x minus 2. And our fraction now is a single fraction in its simplest form. Here we're asked to prove using algebra the sum of 2 consecutive whole numbers is always an odd number. To do that first, we need to let n equal a whole number, any whole number. If n is equal to any whole number, therefore n plus 1 is equal to the next whole number. And that's the consecutive. So we're looking at whole numbers. So n is any whole number, n plus 1 is the next whole number. Therefore, their sum, we're looking here, the sum of 2 consecutive whole numbers. We're looking at n, the first one, plus the second, n plus 1. Simplifying that, we have 2n plus 1. Now, as n is whole number, we can see that 2n is even, and 2n plus 1 is odd.